All right, good afternoon, everyone. Let's see. My name is Stephen Habicht, and I'm the director of the Center for Enterprise Systems Modernization at CNA. A little bit about CNA, we're a nonprofit research and analysis organization, and we're focused on and dedicated to the safety and security of this nation, and that really drives a lot of the work that we pursue. And that's both through the FFRDC with the Department of the Navy, but also through work on the public sector at both the federal, state, and local levels. So one of the areas that we've seen that already has and can continue to benefit from the application of a model-based approach is with UAS, or more commonly referred to as drones. So I'm going to give a little bit of context on the UAS environment, and then focus down on some of the applications for models at the state and local level for implementation. Then after looking at that, I'd like to move forward and look at what's coming down the road in this for these systems, or I guess more accurately in the air for these systems. And then we'll finally take some time to reflect on key takeaways. So in one form or another, I'm imagining everybody in this room is familiar with uncrewed aircraft systems, or UAS. And it's not hard to see why. The use of these systems has exploded over the past decade and continues to do so. So much so that FAA forecasts the use of these systems in operation to nearly double in the next 5 years. And all of this growth will place increased demand on the need for airspace services and air traffic control services to maintain that the airspace system can remain safe and efficient. So the growth of UAS has been propelled by a diverse and ever-increasing set of applications. I have a few shown here, but there are numerous applications out there, and those continue to grow. One that probably gets the most press coverage is the package delivery, with firms like Amazon and Walmart looking for efficiencies in delivery for that last mile. But if you look at things like diverse sets like agriculture, we'll touch on public safety some, and surveillance, there are all areas where the use of UAS has shown to enhance operations compared to their traditional human-based operations. So let's take a look at the operating environment that we're talking about here. The National Airspace System is the network of the U.S. airspace and facilities that make up the aviation operating environment. And the FAA is the regulatory authority that's charged with maintaining the safe and efficient navigation of this airspace. Now, traditionally, that's handled through air traffic management, or ATM, which is a centralized approach where the FAA delivers air traffic control services and maintains the navigation and separation of these aircraft. But with the numbers and applications of UAS continuing to grow, it places increased strain and demand on this system, and the current model can't scale to meet these demands. So enter UAS Traffic Management, or UTM. And that's a federated, more community-based approach where actually the traffic management function is passed down to the UAS operator based on rules set by the FAA. So what is UTM? So as I mentioned, and as shown here in this notional architecture diagram, it's a model where the traffic management function has been delegated to the industry partners, shown here in green. So it plays the network. There's a network of services that are shown here, and the communication among these different operators is paramount to provide that traffic management function. I don't need to go. I'm not necessarily going to go through what each of these mean, but the take-home message is that through the communication of these operators, you can enable the traffic management function for these UAS. So the FAA and NASA have done a lot of great work establishing this concept and laying the groundwork for these operational concepts and requirements to enable this capability. But moving forward, a lot of the success of this system is going to be paramount on the implementation of these UAS programs at the state and local level. So moving forward, let's take a look at some of the applications at the state and local level, and I'm going to focus on public safety for UAS. So again, no shortage of applications for UAS to use here. And if you look at across each of these diverse functions like search and rescue, incident response, surveillance, accident investigation, they all provide numerous benefits to the system, such as increased citizen and officer safety, increased situational awareness, tactical advantages at incident response, and even cost savings compared to similar human-based operations. So with these benefits said, there's no surprise that public safety organizations are taking more and more to implement these systems into their operations. But these organizations face a lot of challenges doing so. So there's technological constraints, so understanding what are the capabilities of these UAS when compared to my mission requirements. Regulatory challenges, how do I know which FAA requirements I need to accomplish or FAA regulations I need to account for with my mission? And a lack of standards. So there's no real blueprint or guidebook to follow in these cases. And there's a quote from police department in Colorado that kind of summarizes this, that the value of UAS is well known and I think agreed upon in many cases, but that once you actually get to going to implement these operations, there are a host of challenges. So enter a model-based approach. So there's an opportunity here to leverage a model-based approach to enable public safety organizations to better implement and integrate these key UAS use cases. There's benefits. I think a lot of folks in this room can espouse the benefits of model-based systems engineering, but in this complex and ever-growing system of systems environment, the ability for different organizations to be able to really assess the impact of changes to their system and be able to rapidly adapt to those is really key for setting up these programs. So one way to look at this as a foundational approach is through four model sets, which I think would be familiar to most people in the room. Your behavior might hold your functions and use cases, things like requirements have your specs and your mission needs, maybe your structure looks at your system, the components needed and interfaces. And then parametrics can show your constraints in the system. And so I'll look at some of the different considerations for UAS implementation at the public safety level through these lenses. So use cases, right? I showed a few. We can walk through some of the different use cases that we've had direct experience with at the law enforcement level. The drone as a first responder is a common use case where drones are the immediate responder to a 911 call to go and assess the situation, gather intelligence, and enable better response from the officer on the scene. Similarly, there's tactical drone deployment. So it's similar for assessing the situation, but might be more tactically deployed at the scene. Maybe the officer pulls it out of the trunk of his car to go assess the situation, maybe flying indoors. And then accident investigations as well. Drones are well suited to fly over an accident scene, gather photos and videos, and transmit that back for analysis by a software platform at the station. Requirements. So if you're looking at use case, this is just a quick introduction of some requirements, but right, for each of these use cases, there are a variety of requirements that are going to determine what you can and can't do when you're implementing. For these drone programs, one of the key areas is the mission. So what is the range? What is the flight time that I need to be able to accomplish this? And I touched on with the overall system, but communication interfaces are key here. There's both the interface between the remote pilot and the aircraft, so for command and control, but then also from the UAS system to the larger UTM system to provide awareness of where you're flying and to be cognizant of where others are flying as well. When you look at the system, you'll go down the line, and based on those requirements, you might look at what components you're going to need across the board. Specifically for the UAS system, sensors are a key point that are going to be necessary based on the mission that you're applying, and a payload. Oftentimes, too, these drones might carry a payload to a certain place, and that has to be considered. Also, the ground control station is needed to act as a flight controller, but also have a software platform. So these are further aspects to look at for the UAS. And then finally, constraints across the board. So these are including the environment where you're operating, and that's both from the physical environment, which can include things like your terrain and weather, but also the airspace environment, which is key here, because you have to be cognizant of those restricted zones. And if you're operating near any of those restricted zones, special procedures have to be in place to ensure that there's no interaction there. And then also the FAA regulations that are required to have your mission set up and put into place. Based on where you're flying, what your mission is, or what your needs are, there are a variety of different regulations, and those come with different prerequisite requirements and lead times to set up the program. So far I've talked a lot about some of the challenges and approaches for establishing a UAS program for public safety in today's landscape and environment. But like any emerging technology, this landscape is continually evolving and growing. So as we're continuing to maintain and look at how public safety organizations can adapt, what's next? Well, for one, it's the continuing expansion of the UAS applications within public safety and across the board. This graphic shows some of the growth factors expected just for public safety UAS alone. And while you can see there might be different considerations in each region that allows for faster growth across the board, the idea is that there will be growth in the public safety arena and increasing congestion and complexity that these different organizations will have to account for in their mission. And if we look beyond UAS, what are the other new entrants that are going to be entering the airspace system moving forward? Advanced air mobility is one that's focusing on larger uncrewed systems that would carry passengers and cargo from different locations and regions. Think the implementation of air taxis and things of that like. And that's where urban air mobility comes in. Urban air mobility is a subset of AAM that's focused on these uncrewed operations, but specifically in an urban environment. And then also you have upper class E traffic management, or ETM, which is focused on operations above 60,000 feet. And that there's technological advances that are enabling increased operations in that space, which previously was for the most part empty. Think the coming back of supersonic passenger flights. All of these additional entrants, when we think of UAS growth plus additional uncrewed entrants, new entrants, and the crewed aviation, the traditional aviation is not going anywhere. So you've got an increasingly congested and more complex system that has to be accounted for. And finally, with the integration of these new concepts, you're looking at integrated regional corridors that can come into play, which again, you're looking at different avenues where these different vehicles may operate, but again is providing another complex area that folks have to adapt to when they have these missions in place, and they're looking to have these operations continue to move forward. All right, so let's reflect on some takeaways here. So with this changing and complex space, really, and we're looking at implementation for public safety organizations, for state and local organizations. There's real value in taking a model-based approach so that these organizations can better adapt to changes that will come through and will continue to increase. A holistic view of these different use cases and requirements can also enable shared solutions. So as different organizations are looking to work through these, they can leverage the benefits of a UAS system or program within their operations, but also be able to realize those on what are often limited budgets throughout these organizations. And then by having an integrated model, it allows the jurisdictions to more effectively respond to the changes that are coming down the road. And that could be changes in regulation. There can be changes in local regulations, in FAA regulations, but also the addition of new entrants or addition of increased operations in their mission space and how to adapt to that moving forward. So with that, I would like to thank everyone for your attention here today. And I'm always interested to continue the conversation. For those of you who are online, there's my email address. And for those of you here, happy to talk after and between sessions for the conference going forward. So thank you very much.